Hi guys, today we'll be solving Leetcode question 560, subarray sum equals k. So we are given an array of integers, nums, and in integer k, we have to return the total number of subarrays in this array which add up to k. So let's try and solve this. So whenever we are solving a question, we should always try to think of the brute force approach, and eventually we should try to get to the optimal solution and then the most optimized solution. So what we could do is, when we think about the brute force approach, we could try to make every possible array subarray, and then we should try and find if anything adds up to the sum of 7 or sum of k. In this case it is 7. So what we would do is, we would have a pointer I and we'll keep a variable sum. So what I will be doing is, the pointer I will go from 0 all the way till n, and the sum will be equal to array of I. If sum is equal to k, we'll add it to the count. And then from the very next element of I, we'll start to make the next make the subarray. So j will always start from the element, so the position next to I, and we'll try to add it to the, so the sum previously was 3, and after the introduction of j, the sum becomes 3 plus the position j, and it becomes 7. So this is equal to 7. So we'll be incrementing the counter. So j will go from I plus 1 to n, and we'll keep on adding it to sum. And if the sum is equal to k, we'll increment the count. So let's do a dry run for a couple of elements, because as we can see, there is a nested for loop. In this case, it will be going to a time complexity of n square because of the nested loops. So the count is currently 1, and then j will go to the next element. The sum becomes 14. 14 is not equal to 7. We'll keep moving j. 14 plus 2 becomes 16. 16 is not equal to 7. We'll move ahead. 13. 14 is not equal to 7, and so on. So we are done with this, and after the first iteration of I, we have got count is equal to 1. Now we'll start with the second iteration of I. 4. So the sum is 4 and the count is 1. So this is I, and j will start from here. The sum will become 11. 11 is not equal to 7, so we'll just keep moving forward. Sum becomes 13, not equal to 7. We'll move forward. Sum becomes 10, not equal to 7. We'll keep moving forward, and we'll not end up with 7 in this entire subarray, so we'll keep moving forward. So now the subarray is 7. we increment the count, it becomes 2, we keep moving forward, this is I, this is j, sum becomes 9, so it becomes, so 9 is not equal to 7, we keep moving forward, it becomes 6, then we move forward, it becomes 6 plus 1 becomes 7, so we increment the count 3, and all the way here nothing will add up to 7 in the this subarray, so we'll move forward. So the sum is 2 now, and we have to keep on iterating it all the way up till the last element. So as you can see, the time complexity is going O of n square, and the final count in this case would be 6. So there is a better and optimized version of doing this, and let me try to explain it to you. So what we could do is, first we need to understand the concept. If the sum of this subarray is m and the entire array is m plus k, then automatically the remaining part of this array will sum up to k. So what we have to try to do is, we have to find a subarray whose sum is m plus k and subarray sum equal to m exists in the stored subarray sums. What it means is, we have to find a subarray sum which is equal to m plus k, and then we have to check in the stored subarray sum if there exists a subarray sum whose sum was equal to m from the stored array. So what we'll be using is a hash map. Let's try to understand it with the same example. So we'll make a hash map. So it will have sum and frequency. So we'll start with 0. Initially the sum will be 0 and it has a frequency of 1. Then we'll start with the first element, I. So the sum is currently 3 and the frequency is 1. Then we move forward. The sum is now 7 and the frequency is 1. So as soon as sum becomes 7, we'll increment the counter. And we'll keep moving forward. So the sum is now 14. 7 plus 7 become 14. The sum is now 14 and its frequency is 1. What we have to find out in every cases when the sum was 0, we have to find out if 0 minus 7, that is m minus 7, does it exist in the hash map. Minus 7 does not exist in the hash map, so we'll not add anything to the count. 3 minus 7 becomes minus 4, it does not exist in the hash map, so we'll not add anything to the count. 7 minus 7, 0 exists in the hash map, so we will add the frequency of this number, that is m minus k. The frequency of m minus k will be added to the hash map. That is the basic concept in this approach. I hope you are understanding. So in this case, 14 minus 7 is 7. So we will add the frequency of 14 minus 7, that is 7. The frequency of 7 is 1. We will add it to the count. So it becomes 2. Then we'll keep moving forward. So I is here and the sum becomes 16. 16 minus 7, 11. Does 11 exist in the hash map? No, it does not. So we'll keep moving forward, and before that we'll increment or we'll update the hash map 1. Minus 3. So the sum becomes 13. Does 13 minus 7, that is 6, does it exist in the hash map? 6 does not exist in the hash map, so we'll not add anything to the count. We'll keep moving forward, but before that we'll update the hash map 1. Then we'll increment 14. We see that 14 is repeated. So what we'll do is 14 minus 7, does it exist in the hash map? Yes, it does. So we'll increment that. And we'll also increment, and we will increment and we'll add the number of, before incrementing we will check what is the frequency of 7. It was 1, so we'll add it to the hash map, we'll add it to the count, and after that we'll increment the hash map as well as the sum. We'll keep moving forward. So 14 plus 4 is 18. Does 18 exist? 18 minus 7, 11 exist in the hash map. Let's check. 11 does not exist in the hash map. So we'll keep moving forward. We'll update the hash map. 18, 1. We'll keep moving forward. 18 plus 2, that is 20. 20 minus 7 is 13. Does 13 exist in the hash map? Yes, it does. So we'll add the frequency of 13 to the count. So it becomes 4. And we will increment or update the hash map. The next element is 1. So the sum becomes 21. And we check, does 21 minus 7, that is 14, exist in the hash map? It does, and its frequency is 2. So we'll increment the counter by the frequency of m minus k, that is 14. 14's frequency is 2, so we'll make it 6, and 6 is the answer in this case. Let's try to find out if there are 6 subarrays whose sum is 7 or not. Let us try to find out the subarrays that add up to 7. This is the first subarray, this is the second, third, fourth, fifth, and sixth subarray that add up to 7. So you can see this is the C++ code. This is the Java code. If you like this tutorial, do share and subscribe.